So this now brings us to our final keynote speaker, and I am so very excited to introduce to you another good friend of mine, Dr. Jyotika Virmani. She is the new executive director of the Schmidt Ocean Institute, and we are so excited about her ascending to that role. We at Esri have been working off and on with Schmidt over the years, but we are now looking forward to an even closer collaboration with Schmidt. And Dr. Virmani's presentation is going to be a combination of certainly a lot of ocean, perhaps some climate and weather, but really more about exploration and partnerships. And one of the things that is so exciting about Schmidt is all of the different partnerships that they have right now. And they also operate their own research vessel, the Falkor. This is a philanthropic vessel that's dedicated to exploring the ocean and mapping the seafloor, which is near and dear to the hearts of many of us who are at this meeting. Now, prior to joining the Schmidt Ocean Institute, though, Dr. Virmani was the executive director of Planet and Environment at X Prize, which many of us know about and follow. And she was going to get Esri involved and has gotten Esri involved in the Rainforest X Prize, which is a competition for innovations in biodiversity assessment technology. So we are very excited about that. She was also the executive director of the Shell Ocean Discovery X Prize, which we have talked about at the last couple of ocean forums. And for those of you who know about this exciting competition, it was all about spurring innovations of unmanned and autonomous deep sea technologies to allow the global bathymetric community to map the ocean floor by 2030. You know, this is part of the big Seabed 2030 initiative, which you'll be hearing more about as well. And embedded in that X Prize was a NOAA bonus prize for technologies that could detect a biological or chemical signal underwater and then autonomously track that to its source. So that was a fantastic competition. The winners of that competition are regulars at our events. So we have been really excited about that. Now, Jyotika joined X Prize in 2014 as the technical director for the Wendy Schmidt Ocean Health X Prize, which is when I first became aware of X Prize. That was a competition about advancing pH sensor development to measure ocean acidification. So Jyotika she's just really cool because she, I mean, I could go on and on. She's a physical oceanographer by training. She was trained at the University of South Florida. She was also an atmospheric science student and took that degree from SUNY at Stony Brook. She has her BSc in physics from the Imperial College London, and she's an associate of the Royal College of Science. And I think she and I are both planning to retire in Cornwall in the UK at some point. Anyway, I don't want to take up all the time for her bio, which is substantial, but one last thing is that Jyotika, in her spare time, she writes a very informative tropical storms blog, which you should really check out. And she has produced an award-winning short science fiction film called Hashtag. Hashtag blew my mind. Go to YouTube, search for Hashtag and enjoy. But in the meantime, Jyotika, thank you so much. We are so excited to have you with us and to hear what you have to say. So I will finally now pass over to you.
Wow, thank you, Dawn. Wow, that is an incredible introduction. And so I'll just take questions from here on. No, I'm kidding. So let me start sharing my screen. But I do appreciate that fantastic introduction, Dawn. Some of the stuff I'm going to touch on lightly, I think, now that you've already talked to the audience about this. But I have been a very long time fan of Esri, so I am very honored to be invited here as a guest speaker today. As Dawn mentioned, I was the executive director for Planet Environment at X Prize. And this was launched in 2015 when about 5% of our seafloor had been mapped to any decent resolution. And so this year, we're now up to 20%, which is phenomenal. And so the goal is seabed 2030 suggests is to have the entire seafloor mapped by 2030. When we launched this competition, though, the estimate was that it would take, this is back in 2015, using the technology of that day, it would take something like 200 to 600 years to map the seafloor at the resolution that we're now looking towards for 2030. And I was fortunate actually to have Dawn as part of our advisory board on this competition, which was wonderful as we had lots of adventures and ups and downs throughout the competition. But the driving force behind both X Prize and the Schmidt Ocean Institute is this intent to use sophisticated marine technologies to scale up our abilities to explore and discover the ocean and to really understand what lies in that 71% of the planet that's hidden beyond our coastline. And so through that, you know, in addition to mapping, we want to unveil the history and the mystery and the wonder that's hidden underneath the sea surface. Esri was one of our amazing partners for the Ocean Discovery X Prize. They provided ArcGIS online software for the teams to use so that they could present their mapping data in a uniform manner to the judges. And we actually also worked with many people at Esri to develop software specifically and software tools for the competition so that judges could use the team entries and compare it really rigorously against the baseline map, the gold standard baseline map, which we got from Fugro and Ocean Infinity. And I wanted to just show you the final competition area for that competition, which was off Greece. And that's the map that you see here. The first round was off Puerto Rico, but that's a story for another day. But this was the final competition test. It took place in November and December of 2018, where 5 teams attempted to gather the bathymetric data from around 500 square kilometers of this competition area off Kalamata in Greece in the Mediterranean. I really also wanted to show you this because there's another interesting use for this particular map, not just as a piece of the X Prize history now, but it's of huge scientific international importance because the next generation of neutrino telescopes, it's a project, KM3Net. This is one of the locations for one of the detectors for that telescope. It's on the western side of this area that's been mapped, which is why it sort of jogs. We really wanted it to jog to the north so we could also feed into this enormous project. And they needed good bathymetric data to scope out their construction site for this telescope. And in case you're not aware, neutrinos are high energy particles that hit the Earth from space. And the way to detect them is after they've traveled through a body of water, they slow down, I guess, enough for us to be able to detect it. So I think it's really exciting that bathymetric mapping is part of this astronomy and physics project. And it really shows that the knowledge of the ocean floor isn't just for those who are interested in the ocean. So the overall goal of that X Prize was to spur innovation. And so and approximately 10 years after the award, which took place in 2019, we would have the technologies to help map 100% of the seafloor. And I think, you know, collectively that will happen. I was actually at the fateful Forum for Ocean Floor Mapping, for the Future of Ocean Floor Mapping meeting in 2016, along with Dawn, where I gave an address to the audience to tell them about this competition. So that was the forum that kind of set the stage for Seabed 2030 and actually turned out to be where I recruited what turned out to be the winning team for X Prize. So that was a phenomenal event. But what I'd like to do is actually travel a little back in time and take us through this journey. So humans have evolved in the last 150,000 or so years without sophisticated technologies, but they've been able to explore the land that we live on in an atmosphere that we can breathe. But not only explore, they've used their ingenuity to live in the most difficult of places on solid Earth. This image is in Meteora, Greece, where monasteries such as the one that's shown here were built hundreds of years ago on top of these immense vertical rock pillars, with the building materials being hoisted up these cliff sides with the technology of the day, which were pulleys and levers and ropes. And so it's amazing what human ingenuity has done to date. But we've, of course, advanced, and so too has our technology continued to evolve. And our world is now way more connected than it's ever been. We have new capabilities that allow us to achieve more and go to places we've never been to before, barring, pandemic-related restrictions. So we're living in an era where technological innovation is happening globally. It's happening at an exponential scale, and it's faster and faster. So quickly, just to put exponential growth into a little technological perspective, here's an example from data storage. So in the 1950s, it would cost around $120,000 to store 5 megabytes of data, which is unimaginable in this day. And you'd need a forklift to take that device anywhere to do that kind of storage capability. By the way, this black and white picture, this 5 megabyte device could store 6 of these images, and that was it. So now you fast forward to 2005, so around 50 years later. Technology for 128 megabyte storage was $99. And then just 10 years later, 128 gigabytes was $40. And so you can see how this is exponentially improving in time. But it's not just data storage. We're looking at amazing time, not just 2020, but in general, because we are in this technological revolution. And there's huge leaps in artificial intelligence and machine learning and robotics and virtual reality and all of these that really pave the way for us to be able to explore and discover our own ocean. So it's in recognition of these changes in technologies and the amazing possibilities that it opens up for humans to explore our planet and uncover these wonders that Eric and Wendy Schmidt established the Schmidt Ocean Institute in 2009. And you see here the vessel that Dawn referred to. This is our research vessel, Falkor. It's named after the luck dragon in Neverending Story, and it's a sophisticated, fully equipped research vessel. And this was established because it was in the recognition that one of the reasons we don't know our oceans is it's a hugely expensive endeavor to go to sea for scientists and for marine technology developers. And so we provide this vessel at no cost to scientists and tech developers from around the world, including the labs on board and the robotic tools. And we have a high-performance computing facility. And these are made freely available to scientists, as I said, internationally, to do their research and to conduct cutting-edge science and test technology. And in exchange, we ask that they make their data and their research and findings publicly available in a spirit of open data sharing, in the understanding that the faster and the more we can share, the faster is our ability to understand and then protect the oceans. So it's definitely been a challenging year for marine operations globally, but we were really lucky to continue operations with the Falkor throughout this year, partly because we were already on a series of expeditions around Australia when the pandemic started to take hold in mid-March, and partly because we have, a great crew who volunteer to stay on beyond their shifts, staff, and then also the technology. And I wanted to take a quick moment to share this exciting discovery that was made in April of this year. We serendipitously captured this amazing siphonophore off Western Australia. It's believed to be the longest sea creature at 50 meters in length, 150 feet. So this was my first, the first cruise when I was at the helm of SOI. I wasn't on board, but it was phenomenal to see this. But what's really striking to me about this is it highlights how vast and unexplored our ocean is, and the fact that a creature of this size was just seen for the first time just a few months ago means we've got a long way to go and a lot to find out. And the only way to do that, I think, is through technology. But in addition to the Falcor, we have a very sophisticated remotely operated vehicle, Sebastian, keeping to that never-ending story theme there. That's shown here. It can go down to 4,500 meter depth. It's equipped with 4K cameras and a number of different sampling capabilities. And we also have a very advanced communication system on board, which was lucky because over the summer we stopped allowing scientists on board. So we were able to conduct fully telepresence cruises, which has helped, to continue those operations throughout the year as scientists collaborate and tune in from their living rooms, and as we broadcast live with a very minimal crew and an ROV operations team on board. So a key part of our exploration and our mission at sea includes mapping the bathymetry at high resolution. And we've done that throughout the year, both with and without, as I said, scientists on board. Last year, we signed an MOU and have a partnership agreement with Seabed 2030. And I know Esri and Dawn, you're very much involved in this as well and a key leader in this global effort. As I mentioned earlier, only 20% of the seafloor has been mapped. And we've contributed about over 1 million square kilometers to that JEBCO database. And we'll continue to add to that, of course, as we continue with the new high resolution bathymetry that we've been collecting around Australia this year. And the overall goal of Seabed 2030 is to create a map of the entire seafloor to high resolution, just as we have on land. Yet with so much of the world that's yet to be mapped, it's actually not surprising that new discoveries are being made every day. So in case you missed the news this last week, I'm going to share this video as I talk about this. This is on the Great Barrier Reef. On October 20th, the Falcor was mapping the northern edge of the Great Barrier Reef, and we found a 500-meter tall, new detached reef. That's right here where my cursor is. I'm hoping you can see that. On the ledge of the Great Barrier Reef, and it's the first one that's been found in 120 years. So the last time this area was mapped was, in the 1800s, late 1800s, using lead line, so dropping a weight on a rope over the edge and seeing when it hit bottom. This reef, by the way, is taller than the New York Empire State Building, and the base of the blade-like reef is about 1.5 kilometers wide, and it rises, as I said, to 500 meters, with the shallowest depth actually 40 meters below sea surface. So it's not easily visible from the surface. This discovery now adds to another 7 tall detached reefs that are in this area, including actually a well-known reef, Rain Island, which is the world's most important green sea turtle nesting area. So that was really exciting. Because we had the ROV on board, we actually dove on it last weekend, a week ago on Sunday, and it's a really healthy reef, full of life. The Great Barrier Reef is, of course, well known, the world's largest coral reef, home to more than 1,500 species of fish, and it stretches 1,400 or so miles, and is a World Heritage Site. And so it's really great, given all the stories we do hear about coral bleaching, and parts of the Great Barrier Reef have had that this year. But it was really great to see something so vibrant and alive. And we actually also serendipitously caught last Monday, the first in the wild observation of this squid, the Spirula spirula, or ram's horn squid, alive in its natural environment. This has never been seen in the ocean before. And it had the squid scientific community aflutter, because those that are in captivity that have been caught through a net, they always swim with their eye downwards. And so, this has turned the scientific theories around how this squid lives in the wild upside down. All puns are intended, just in case you were wondering there. So this was really an exciting new thing as well. But back to exploration and mapping. So I believe the goals of SIBA 2030 can be met because we've seen this increase in technology in recent years. So this is a photo showing Sail Drone. It's an unmanned surface vessel. It was a grantee from the Schmidt Marine Technology Partners, which is one of the Schmidt Ocean Entity's sister organizations. And we used this to gather data before the Falcor got to the location of study. And so Sail Drone has a data service model, which allows those who can't or don't want to own their own technology to still gather data and conduct research at sea. So what this also shows, though, is in addition to funding the scientific research that doesn't necessarily fit into a single country or company's agenda, philanthropy also funds some of these high-risk investments that are in their earlier stages of technology development, as well as funding the scientific research. Another example, this is the part of the winning entry from the Shell Ocean Discovery X Prize is SeaKit, and I won't really go into this in too much detail, but in August this did map complete a 3-week mapping cruise in the Atlantic with no one on board, all controlled remotely with minimal fuel use. Fugro is actually spearheading the utilization of this technology. And then just actually a note before I forget, so Dawn had mentioned that we had a bonus prize from NOAA for autonomous technologies to detect a chemical or biological signal underwater. That was actually won by a junior high and high school student team, which really shows, and so, you know, they were really very pleasantly surprised to win $800,000 last year. But it shows that innovation can come from anywhere, and it's actually already coming from everywhere. Going back to the SeaKit, the breakthrough for this technology and others that emerged from that X Prize was the ability to have unmanned deployment and recovery at sea of AUVs for seafloor mapping. So essentially the ability to deploy and recover a robot at sea using another robot with humans sitting on land in a control room, monitoring and controlling the mission, just like NASA does for robots that it sends into space. But it's not just, submersibles and unmanned or autonomous robots in swarms that are where the technology is advancing. It's going up through the water column and up into the atmosphere. This is an image from the end of last year. This is a cruise. The lead scientist was Dr. Chris Sapper from Columbia University. And this was technology to study the sea surface microlayer, which is notoriously difficult, of course, to study because it's the boundary between the ocean and atmosphere, but it does play a huge role in global air-sea interactions and weather forecasting. And this one in particular was used to look at the effects of Trichodesmium cyanobacterius off Fiji. There's also, over the last couple of years, SOI has tested eDNA, artificial intelligence, as well as novel sampling systems. These, what you see here, are squishy fingers, which were 3D printed on board the Falcor. And these help to gather delicate specimens. So a significant number of deep sea species remain undescribed because they can't be brought back to the surface in good enough condition for taxonomic inspection. So this kind of technology really advances how we sample in the ocean. But it's of course not just ROVs. We can also deploy instruments on moorings and landers, such as the one that's shown here. This was from a cruise led by Dr. Mandy Joy from the University of Georgia, looking at the microbial community structure in the Gulf of California at 2,000 meters depth. So the Gulf of California is a young ocean. It's undergoing change, such as seafloor spreading, and there's a lot of hydrothermal activity there. And what they discovered was really beautiful. It's this amazing superheated hydrothermal vent with this underwater mirror-like feature. And it's just spectacular. So, but you know, although there's such beauty down there in deep places that no one has been to before, we unfortunately on this cruise did find our footprint in the form of plastic and rubbish down there, which really goes to show, even if it's out of sight, how deeply we are connected with the ocean and places that we can't see. But on board the Falcor, we've actually had a lot of cruises that have been involved with technology development using an assorted of unmanned technologies. And this slide gives a very brief snapshot of some of them. But it's not just hardware, it's also our ability to actually visualize the ocean is changing. So this is using, virtual reality. This particular expedition was to ground truth satellite data with respect to particles in the ocean. And you see here on board personnel using VR to view plankton communities that were imaged through holographic cameras. On another cruise, scientists from GeoMar Helmholtz Center in Germany developed the first 3D model of an entire hydrothermal vent field for VR. And this was off Fiji. So the advent of this sophisticated and high resolution VR and AR technology allows us to, not just scientists, but a broader audience to experience the ocean in ways that we've only previously seen in science fiction movies. And they're really clarifying and bringing new ways of viewing and conducting science. And so I just want to quickly end with a little bit about looking into the future and wrap this up with some examples of technology that's happening outside the marine industry that I think we can tap into in the next decade. So first in communications. So we're now, of course, on track to have cheap, low latency, high speed global coverage soon with the low Earth orbiting system satellites. So the Starlink network, for example, is already in beta testing phase. And this is going to revolutionize our ability to communicate from the high seas back to land. I still remember very clearly the days of being a graduate student at sea and only being allowed to send or receive one email a day. So this is really going to change how we do operations at sea and allow for that scaling up of mapping and autonomous technologies. The field of material science is changing rapidly as well, and so along with that is the promise of new and different power sources or other capabilities. So what you see here is from KAUST. It's an ultra-thin organic solar panel on an air bubble. And this has really been like a long-standing goal in material science. So something like a coating of this in the future could maybe remove the need for batteries and make, so we'd have lightweight sources of sensors or moorings out there or on surface vessels. And finally, the integration of many of these different technologies is already underway. So I'm going to bring this back to X Prize. The Avatar X Prize is to push on the development of an integrated haptic suit that's worn by humans and a physical robot avatar. So the avatar allows us to see, smell, feel, touch items that are in a remote location in real time and enable the human operator to interact with the environment as if they're truly there. And so, for example, in the future, this is just an example from Stanford Robotics Lab, but you can imagine a future where instead of sitting on a park bench watching birds fly by, you'll have your haptic suit on and you can be sitting in an underwater bench looking at this new coral reef that we just found and watch the fish swim by. So that's going to change how we do things in the future. So as technology evolves, our ability to explore is obviously evolving. And we can see things from the strangest seafloor landscapes to the smallest of creatures, like this 1 centimeter pygmy seahorse that was seen in August of this year in the Coral Sea with the ROV Sebastian. By the way, if you haven't spotted it yet, it's right here in the center, the lower center of the screen. And this was seen by Sebastian. So that's like driving a car and seeing a safety pin on the pavement. That's how remarkable our technology underwater has got to. And so finally, as we look forward towards the UN Decade of Ocean Science for Sustainable Development Goals, which we are a part of as well, I know that the technology that we have has a role to play. And I really think, their motto is the science we need for the ocean we want. pivots around the technology that we have to have. And because of that, I know that by the end of the decade, we will have a wonderfully high resolution seafloor map. That's something that we at SOI, at Esri, JEBCO, SEBA 2030, and a lot of our friends and partners are collectively working towards bring about. And to me, a map is a fundamental piece of understanding of where we are in the universe, what's out there. And because of this goal, I think the science that's going to be done at the end of the decade is going to be different from the start of the decade, because this is really a new golden age of ocean exploration. So with that, I would like to say thank you very much for inviting me.
That was terrific, Jyotika. Thank you so much. So many mind-blowing discoveries just in the last couple of weeks, it seems. For our audience, if you don't follow the Schmidt Ocean Institute on Twitter or other forms of social media, I would highly recommend it, because it is so entertaining and so inspiring. And Jyotika, didn't your institute just get an award, a media award?
Yeah.
Could you mention that as well?
Yeah, that got lost in all the other stuff. Yeah, last week we also won the Maritime Media Award for best use of digital media to convey all of this to the public. So our website and social media is featured highly in that. So we're very grateful for that. It's a great honor.
Fantastic. Congratulations again. I love how artistry is infused in our theme this morning. So we have a few questions here. So I'm going to take up a little bit more of your time with these questions before we let you go. So the first question from Daniel: amazing presentation, technologies and discoveries from ocean floor and the seabed. How does Schmidt Ocean Institute cope with requests to use the vessels and tools from your researchers across the globe?
Yeah, that's a good question. So we usually have a call for proposals. We didn't this year. They had the foresight to know there'd be a new executive director, i.e. it turned out to be me, of course. So we've actually planned for until 2022. We're actually fairly booked. However, having said that, obviously they didn't plan for the pandemic, so we've had to shift and change. So if somebody has got something in mind, I would, at this point at least, say please reach out, because if there is a moment of opportunity, we're trying to utilize this asset to the greatest capabilities that we can. Our plan is now to probably stay around Australia at least into the first quarter of next year, and then start transitioning back across the Pacific.
And I gathered from your remarks that the Schmidt Ocean Institute assets are for everyone globally, correct? Because you work, of course, with scientists from the US. You mentioned, of course, Australians, Germans. What are the countries that you're working with the most right now?
Oh, well, right now we've been around Australia, which has been great because they don't have a lot of cases. However, the other side to that is they have a very strict travel restriction bubble. So we're actually working with Australian scientists, but what we have been able to do with telepresence and live streaming the dives and having that interaction is actually have scientists participate from around the world. So, you know, in the last couple of expeditions, we've had someone from Japan and other, you know, there's a whole host of countries. They're from all over. I actually don't know where they're all from because it's all, you know, YouTube chat. And so it's really great, though, to see that interaction globally.
It is. It's great. And Schmidt is such a boon to our community, given the lack of government funding right now as well. Another question from the audience: what innovation are you looking forward to the most?
Ooh, that's a great question. I think for the ocean, at least, if we can really crack underwater communications, then we can interact the same way we do on land and have technology that talks to each other. But of course, doing it in a way that does not harm the marine life is the key. So that's a really boring answer, I'm sure. I am looking forward to the avatar technology that I showed at the end there. That's perhaps a more interesting answer. But the usefulness of that technology, other than, you know, sitting on a coral sea park bench, is if we have something like a disaster, like an earthquake, instead of sending in, like in Turkey, right? Instead of sending in people, you'd send in the robot avatar controlled by the experts. Same thing for a nuclear disaster. Or if there's an area that does not have medical facilities, and we've seen that this year with telepresence, medical telepresence, you could have a doctor jump into the avatar an hour here from this place and an hour there from that place, providing that community with medical expert knowledge in a way that we don't currently have, but not a huge drain on the doctors, necessarily the doctor's time. So anyway, that is a very useful piece of technology that I'm looking forward to.
Boy, it's, we could have a whole conference about that. Okay, a couple more questions here. Caitlin says, amazing and inspiring presentation. I learned so much about the importance of technology and our future with ocean exploration. What is your advice for a young adult who would like to be in a career like this? Any tips or suggestions?
Great question. I think technology has really opened up a whole new way for a new generation, you know, the next generation and young career, those who are younger in your career to participate. So I'd mentioned, you know, the junior high and high school student team. If there's something that you're really interested in, then you have that capability that we never had of going online and seeing what's going out there. So don't lose that passion, that interest. And then career-wise, I think we still need, if you want to get into technology, a solid understanding of engineering principles, of scientific knowledge. So, you know, mathematics, those are really, really all important. So career-wise, definitely as a basis, I would make sure you double down on some of those.
Yeah, I would agree. One last question before we let you go, or actually a greeting to Sam, who is participating from Nigeria. So we are very eager to find out about the international composition of our audience over today and tomorrow. But so hello, Sam. And from Monica, are you finding that the newly discovered reefs are being created with slight adaptations to climate change, or is it too soon to tell?
For this particular one, I think it was because it sits 40 meters below the sea surface, so it's a little cooler. It's in the northern Great Barrier Reef. It's in a very remote place, so there's not so much pollution and human interaction. It's, you know, it's undiscovered, so it's relatively pristine. Having said that, in the northern Great Barrier Reef, on some of the dives, we've also seen plastic. So even though these areas are remote, like I mentioned with the Gulf of California, that sneaky stuff is getting everywhere, and that's a different problem that I know people are working towards.
Yes, we have a couple of talks over our event that will talk about the plastics problem. Everybody is talking about it now, which is great because we need that.
Yeah.
Well, Jyotika, this was a delight. We are so looking forward to working with you and with Schmidt on several fronts, SOI and ESRI. And I'm also looking forward to your next science fiction film in your copious spare time. I don't know how you do it. But thank you so very much for this fantastic talk.
Thank you, Dawn. It's been a real pleasure and an honor. Thanks.